Welcome! Today we will analyze how a force speed operating point of the powertrain translates into different operating points of the engine when different gears are used. Depending on which traction force and speed the powertrain shall operate at, only some of the gears may be possible to use. This lecture will show why that is and when the different gears can be used. This is a force-speed diagram with the different operating ranges for the 5 gears overlaid on each other. This is, by the way, the same powertrain as introduced previously. A specific driving situation can be represented by an operating point in this diagram. Now we assume that the powertrain must supply about 1100 Newton of force at 65 km per hour. This requires 20 kW of propulsion power. Next, we will look at how this operating point fit within the operating range of the 5 gears. Notice that when we change gear, that the operating point in force and speed remains constant. It's only the possible operating ranges which will change with gear. This is what happens on the first gear. The operating point is in the upper part of the possible speed range, but in the lower part of the force range. This means that the engine in this driving situation and in first gear will operate at a high shaft speed and low engine torque. The torque will be only about 1/5 of the maximum torque of the engine. In second gear, the same force speed operating point ends up in the middle of the operating range. This is because the total ratio of the transmission from engine to wheels is lower on the second gear than on the first gear. As a result, the engine will operate at lower shaft speed on second gear. The engine torque is higher than on the first gear, but only about 1/3 of the available engine torque. Remember, the force speed diagram for each individual gear is a scaled version of the engine map. In third gear, the operating point will lead to an even lower engine speed and higher engine torque, now about half the available torque. And even lower shaft speed and a higher torque on the fourth gear. In fifth gear, the engine torque is on maximum limit for the engine, and the shaft speed is close to the minimum engine speed. Notice that all these 5 engine operating points we have studied are representing the exact same driving situation, but with different gears selected. Now we will look at the same driving situation, but from the perspective of the engine. We have earlier derived this transmission model which links an operating point for the vehicle to the corresponding operating point of the engine, or vice versa. In this case, we have a fixed operating point in force and speed, but change the gear. That will give us 5 different torque shaft speed operating points for the engine. This is the torque speed operating range of the engine in the analyzed powertrain. This is the operating point we get on the first gear. If you compare to the force speed diagram in the upper corner, you can see that it is the same operating point for the engine. The second gear gives us this operating point, and third, and fourth, and fifth. This is the only 5 engine operating points the engine can have in this specific driving situation. If we plot a line showing all operating points which provides 20 kW power from the engine, we get this red line. 20 kW was the traction power required in the analyzed driving situation, and of course all the engine operating points end up on this line. Since the gearbox cannot add any power, it just transforms speed and torque. Now we will make the same type of analysis, but for another operating point. In this case, the vehicle drives at 120 km per hour and requires a traction force of 1800 Newton, which corresponds to a traction power of 60 kW. This is the operating range on first gear. We clearly see that the point is not within the range. This is because the vehicle cannot drive 120 km per hour on first gear, as that would require a much higher engine speed than 6000 RPM. In second gear, the operating point is still outside the possible operating range, again due to too high engine speed. In third gear, the operating point ends up within the operating range at rather high engine speed and 2/3 of the maximum engine torque. In fourth gear, the engine speed is a little lower and the torque is the maximum limit of the engine. Finally, in fifth gear, the operating point is again outside the possible operating range, this time due to the required torque being higher than what the engine can supply. If we look at this second driving situation from the engine perspective, we again can see that first and second gear cannot be used since they lead to higher engine speeds than 6,000 RPM. Both third and fourth gear are possible as they fall within the possible operating range of the engine, while the fifth gear requires more torque than the engine can deliver. All these operating points sit on a line with 60 kilowatt engine power. Now we have seen that we often can use several gears in a vehicle operating point, but necessarily not all gears. From the force speed operating ranges for the different gears, we can also determine which gears can be used in different driving situations. By making the colors a little transparent, it is possible to see that the operating ranges for the gears overlap more or less, and when they overlap, it means that all the overlapping gears can be used in that region. The borders of the operating regions for the different gears divide the whole operating range of the powertrain into 14 different regions, in which different combinations of gears are possible. For example, in this region, only the first gear is possible to use. And here, only first and second gear are possible, since it is only those two operating regions which overlap in this region. Here, first, second and third gears can be used. This small region is the only one in which all 5 gears can be used. If the speed increase, some gears are no longer possible because they lead to higher engine speed than 6,000 RPM. Here only third, fourth and fifth gear can be used. So, in summary, there are 3 different reasons why gears cannot be used in the whole operating range of the powertrain. The engine speed can become too high or too low, or the engine torque can become too high. Again, we have seen how useful a force vehicle speed diagram can be. In earlier lectures, we have used it to describe the powertrain requirements, analyze the performance of the vehicle, and to help size the powertrain and its gear ratios. In this lecture, we also used it to determine what gears can be used in different driving situations by plotting the operating range on different gears in it. We have also shown how the gear selection influences the torque and shaft speed of the engine, and this will be very useful when analyzing the fuel consumption and when deciding which of the gears is best to use in different driving situations. Please try the following exercises on what gears can be used and how the gear selection influences the engine.